one that close behind you? Thank you. That way my thoroughly destroyed ears will be able to hear you guys. I spent 10 years in a metal band with my foot on an amp. So if I don't hear you in the back, just chuck something at me. Please no Samsung IEDs. We'll talk about container fires here, but we don't want really one of those going on. If you guys, this is a smaller group. If you guys want to keep it interactive, if you have a question, speak up, throw something at me, raise your hand, whatever it is. I'll stop and we'll talk through whatever it is you want. But an intro on this one is this is a Docker security talk. Now, I've heard several people in here actually do Docker containers for a living. I see some grimaces after I said that. So is that raise your hands? How many of you guys work with Docker day to day? There's one. All right. So this is not going to be a real technical deep dive on the actual Docker auditing or anything like that. There's much better people and tools out there. What we're going to talk about is a security program that I built for a customer that wanted to talk about how do I wrap the controls around Docker. How do I integrate my security team with a DevOps team that's trying to move faster and that's trying to be more agile when my security guys keep putting up barricades, right? So what we did is we kind of dove into Docker, decided whether or not we were ready for Docker, and then wrapped a program around that Docker security presence so that we had a good way of building out from there. So from that perspective, who am I, right? Guy up here talking. My name's Chris Huntington. I'm the Chief Information Security Officer for a company called Nexigen in Newport, Kentucky. I've been a technology enthusiast and security evangelist since 2004, slinging in really, really old firewalls and doing work for the state of Illinois and a few other places up in the Chicago area, and then moved down to Cincinnati a few years ago. Various certifications, none of those matter. Nobody really cares about them, I'm sure, but just recently passed the CISP, which means I now absolutely know nothing. And a cigar nerd. So half of my Twitter posts you'll find are mostly about cigars. But that's kind of me in a nutshell. I've been with Nexigen for just over a year now, doing a lot of security consulting and building a few programs internally to deal with phishing and to deal with some compliance and retention and log management. So what is Docker? That's what we're really here to talk about, right? This is my favorite infographic ever, and I call it an infographic as opposed to a meme because I really think it is. This is a shipping ships, right? And when you talk about Docker, right, all you hear about is I want to ship, right? And what are you shipping? All right, well, you're shipping containers, right? And what you're shipping in those containers is a pre-built environment, right, that has your application in a portable container, right? We used to talk about VMs and that we would deploy new VMs each time we deployed a new iteration, right? But VMs are slow. VMs are cumbersome. VMs require hardening. VMs require a lot of different processes and a lot of different things to move them between environments, right? Docker eliminates a lot of those things because it doesn't have an operating system. Right? It does, but it's a shared operating system. It doesn't have a lot of the encumbrances of a traditional VM or traditional server environment. Okay. So I got a little slide on here. I won't read the quote out because I hate it when people put a quote on the board and then just stand there and read it. But it's a flexibility tool, right? And it's built for scalability, right, and portability. Scalability above VMs because you can actually move Docker containers across multiple physical hosts, which is pretty cool. Not something you can do really easily with a VM architecture. It allows for a very good communication and collaboration among DevOps teams, right? So what we do, as opposed to shipping code, right, and building code every time we ship to a new environment, what we do is we build a container in Dev, right? We install our prereqs in the container that we have, and we take that container from Dev to QA to production, right? And that container persists throughout the entire lifespan of that iteration of the software. So, as opposed to having to build packages, we're building containers now. right? And we're spending less time deploying code, we're spending less time provisioning VMs, we're spending less time hardening VMs, and we know what's out there every time we ship a new container. Does that make sense, everybody? Am I going too fast, or are we good? All right. The thing about this agility is that it is very, very, very fast. That's why DevOps teams love it, right? But because of that, you can actually get it to a point where you move a little too fast, right? And that's one of the things we'll talk about in our readiness discussion, is that you have to be ready to move this fast, right? You don't go from running a running race against your 4-year-old to sprinting in the Olympics, right? And if you're used to traditional software deployment schedules, Docker is going to throw a wrench in that completely, right? Because people are going to be shipping more often, and you're going to have a lot more contention for the resources than you ever had before. Okay, so that's one of the things you have to understand, is that because of that speed, it comes with some inherent difficulties if you don't communicate well or you don't work in iterative processes. It was released in March of 2013, so it's 3.5 years old. Not really a well-baked-in technology, but it actually works really, really well, believe it or not, because it's simple, right? So March of 2013, it's got all the blue chips as sponsors of it. Red Hat, IBM, Cisco, Google, everybody's pitching in on the Docker side, and it's gaining a lot of foothold all of a sudden. There's Docker cons, there's a lot of things going on in the Docker community already that usually takes a decade to get to, and this has been really quickly adopted because it is piggybacking on the tail of the comet, which is DevOps, right? The current goal, and they keep pushing towards this, and I still don't see how it's going to work, is to be operating system independent, right? So right now, Docker is a Linux platform, right? I can run it on any Linux server. It's built into the kernel. I can run it anywhere I want on any Linux server, and my containers move from Linux server to Linux server without a problem, right? They want to move that to the Windows side, and from what I understand, the Unix, the BSD side as well, which would be pretty interesting. It'd be really kind of cool to be able to ship between different environments and different skill sets and migrate without having a lot of vendor lock-in, which would be really cool to have. Again, I'm not entirely sure how they're going to make that happen, but they say they can do it. So that is the current push. They've also come out with a few new features in the past 6 to 8 months that have really helped with the security side of things. Docker isn't, though, a virtualization technology. A lot of people lump it in with the VMware Hyper-V. What's the Citrix one? Anybody actually? XenApp. Thank you. It's not that, right? And you can't think of it that way. If you start thinking about it as a virtualization technology, you'll start applying the principles of virtualization to it, and it works completely differently, right? There are some similarities in the way that you provision. You provision resources, you provision RAM and CPU, you provision NICs similarly, but if you think about it as a VM and you think about it as something that's going to be there for a long time, it's not that at all. These containers are going to be created and destroyed faster than we've ever created and destroyed VMs, faster than we can create and destroy VMs, right? It's not built to be inherently secure. They didn't look at the kernel and say, "Ooh, this is really secure," right? It's built for agility. And sometimes agility and security don't necessarily go together very well. I'm sure I see a lot of heads nodding at that one, right? We are the Department of No, or at best we're the Department of Yes But, right? And DevOps has gotten to the point where they're saying, well, you said no, so I did it this way, right? So Docker is not, it's built for that agility, it's built for that speed, and it's not made inherently to be secure. Now, we've made some strides over the past few months with 1.10 release and stuff like that. It's also not a virtual sandbox, but it does behave similarly to one. It does use a shared stack, right? So there is a way to break out of that container and move laterally from container to container, right? It's not, because we have a shared platform, it isn't as sandboxed as a VM would be, right? It doesn't have a lot of the functionality that we look for, like vSwitches. We have some of that functionality, but we don't have a really in-depth vSwitch type technology, or some of the other things that we can use to segment VMs very effectively. Okay? And it's not a panacea for application hosting. And I got that in there because I really love the word panacea, for one, and because it's, I hear a lot of DevOps teams saying, well, we're just going to use Docker. Well, have you looked at how it works? Well, no, but everybody's using it. All right, why? Well, because everybody's using it, it's fast, that's what we want. All right, slow your roll. What are we actually doing with this? Okay, that's what we're going to get a little bit further down the line. How does it work? For a long time, LXC, systemd, which everybody loves here. As soon as they say systemd, I see a lot of and libvirt were originally the way that Docker interacted with the Linux kernel, right? And now libcontainer library shipped with, I think, 1.08, if I remember right. And that integrated a lot more with the virtualization functionalities that are built in, like, to the KVM part of the kernel, right? So now we have direct access to a lot of the virtualization features that we didn't have access to before. We kind of had to work around it. That libcontainer library, it uses a lot of the KVM functionality built into the Linux kernel to use things like namespaces, AppArmor, cgroups, all the good stuff that we really want to get to in the kernel to share with that container. It now accesses through libcontainer. We do still use some libvirt and some systemd in that respect, but it's much, much less than we were using it even a year ago, right? 3-year-old technology. So this is moving real fast, and it's sometimes difficult to realize as new iterations come out. 1.10 came out with user namespaces, right? And user namespaces was a monumental shift for the Docker community. And I'd say about half of the people were ready for it. The other half were like, thank God, finally. But about half of the people were ready for it, and they are monitoring software and everything else, but just completely berserk. So look at all these new users, right? So keeping up with what's actually being released before you apply the patches is another thing that you want to understand, but Docker changes every single iteration. It's still very, very, very new. So something to understand. Like I said earlier, a container can span multiple physical hosts. So if you've got a bunch of boxes that you need in production and you want to have specific resources for specific processes, a container can span multiple hosts. Per container, you can assign resource limits to avoid one of your containers DOSing the rest of your containers, right? It does have unique TCP/IP stack per container. Each one has its own TCP/IP stack that's built in, ready to go, and that means your own IP addressing, everything else. You don't have to rely on virtual interfaces the same way we do. The process IDs, obviously, that was part of the namespaces feature, right? Unfortunately, for a long time, the user namespaces wasn't available. So the Docker, a root user in the Docker container, and if you're on 109 or earlier, a root user in the container is a root user on the host, right? That was a whoa when I saw that the first time, right? And when we did this study, we did it before user namespaces was out, but that came out in February and kind of changed the game in that respect. Namespaces gives us that isolation as well. So we use namespaces to assign those resources, right? So each process that have a namespace appended to the beginning, right, can be assigned a specific amount of resources. So you can get very, very granular as well, which is something you can't really do with a VM. And you can get some more granularity. Anybody questions before I move forward? No? Okay. Again, each of the applications run in a container. Network stacks are separate. The containers only contains the dependencies for that application, right? So if one application requires OpenSSL, right? God forbid we have OpenSSL in there again. If one container requires that, that goes in that container, right? And it ships from base install to base install with that configured and attached to that container, which is really kind of cool. It's created at the beginning of the development process. So one of the things we'll see is that in Docker, when you create a container, what's really cool is that you can download containers. Kind of like, it's almost like GitHub for containers, right? There's a container, a Docker hub. Thank you, Docker Hub. And you can grab a container from there, build on that. It's already 90% of the way to where you need it to be, right? We're going to talk about those a little bit more because there were some pretty shocking numbers around the Docker Hub. But that container is built at the beginning, shipped through the process, checked at each one of the stops on the way, and then that container persists all the way into production until the end of your cycle. Usually, if you're agile, usually the end of your sprint. Right? So you're shipping a new container at the end of each development cycle or development sprint. Right? The security benefits, obviously, kernel level controls are in place. Namespaces are great. You have a smaller footprint per container. Right? So now I don't have this big sprawl of machines that I have to patch all the time. Right? I've got to patch base machine on a regular basis, and I have to patch the dependencies in each of the containers, but I don't have 450 Windows machines now that I need to patch, or 450 Docker machine, or Linux machines that I have to patch on a regular basis. So it actually reduces a lot of the patching that we actually have to do, which is really cool. And then the control groups allocate the resources relatively well, right, to prevent one container from eating up all the resources on the base, the host server, which is really, really helpful. That's done again through namespaces. So those are good security benefits, and I love not having to patch servers all the time. Patching is probably the most boring thing in the world. Sitting there waiting, then it doesn't work, then I got to fix something, then I sit there and wait again. Still doesn't work, right? This reduces the amount of patching I have to do, but it doesn't reduce the number of vulnerabilities that I'm going to run across. So, user namespaces, again, was released 1.10, okay? There was an experimental version of 1.9, which only shipped on the Fedora platform, right? And it broke everything, which was a lot of fun to figure out. But 1.10, it went into general release. It maps a root GUID in the container to a non-root GUID outside the container, which helps us a lot with privilege escalation, lateral movement, all the things that we really freak out about when we're hosting a web application, right? Somebody pops my server or my container, what can they do? And before this, if they got a hold of a process, that was a root process on the host. Because it's a root process on the host, anything else that's on there, and God knows we all, a lot of times, end up having the same user across multiple hosts. We got a lot of lateral movement potential, right? So unless we were very, very, very secure, we had a big issue with that. This has solved a lot of those problems, right? We still have credential leakage issues because, I mean, they can just fish one of the administrators saying free coffee or free spicy food. This helps a lot. Again, it means root inside the container is no longer root outside the container, right? But as I saw this upgrade to 1.10 drop, I didn't see a lot of people start to implement this with separate passwords or separate root users, right? So now all of a sudden, yeah, it's not the process isn't the same, but holy crap, password's the same. If I get that, I'm off to the races, right? So you can actually now manage those a little bit more effectively. It's a nightmare to keep all those passwords, and where are you going to keep them? But you can do it, and you can help with privilege escalation in that respect at this point. My security concerns, right, and we're going to talk about these in a little bit more depth. The shared kernel architecture really wasn't designed with security in mind. User namespaces has made a big change. The Docker daemon does run as root, right? So it is a predictable attack surface, right? A lot of daemons run as root, but this one is another one that if people realize you're running Docker, it's an attack surface that they can look at. It is also pre 1.9 or 1.9 and earlier. It was relatively juvenile to escape the sandboxing, right? It's a little bit more difficult now, but again, incomplete integration has seen some issues around incomplete integration and people being able to grab passwords out of config files, right? And that's just bad security, but again, when we're automatically scanning, we're not looking for a password in these libraries, are we? Not very often. Something you want to look at with Docker, though. This is the big one for me. And this is the one that kind of was a deal breaker for us. Last year, and this is a little bit old numbers, I think it goes back to February, 30% of the containers in the Docker Hub contain serious, which is medium or high priority security vulnerabilities. Right? So unless we've got our hands around scanning all of our containers as they go, before they go to production, we have a significant risk of having an incident based around somebody just grabbing a container out of the hub and building on that, right? And if somebody builds on that container that they just grabbed from the hub and then tries to ship it to prod, and we grab it in QA and say, whoa, what is that, right? That's going to be a significant amount of rework. Okay, so how do we deal with that? And that was one of the things that, how many people here are TSA pre-check, global entry pre-check people? Am I the only one? Holy cow. This is a security conference, isn't it? We kind of built a similar pre-check program where the security team is no longer sitting back scanning what's actually on the network. They're being proactive. They're saying, all right, I'm going to grab 10 containers today and I'm going to run Nessus against them. I'm going to check them. And then I'm going to tell the developers, the DevOps guys, all right, hey, these containers are good for you to run for this amount of time. Right? Because when we look at the actual vulnerabilities, that's really hard to see in this one. But all the images in the container hub were 962. The ones with high priority vulnerabilities, 36% had high priority vulnerabilities. Right? So that's, if I remember right, going back, it was a CVSS of 7 or higher, which are the ones that make us pucker a little bit, right? Like, ooh, look what I found. The ones that were triggered the latest, or tagged the latest, which was 73, 23% of those contain high priority vulnerabilities. It's a big number, right? That's a really big number. But these things are getting shipped on a regular basis with companies that haven't wrapped around what this actually means. When I saw these numbers, I saw that, right? And actually, funny enough, about 30% of that ship is actually on fire. So that was definitely what I was looking at. I saw those numbers and I'm like, holy cow, what do we do with this, right? As a vCISO for this customer, right? How am I going to wrap my head around the fact that their devs want to move this fast, right? But I'm going to start getting containers shipped into QA where we start scanning them and we have to reject them, the entire container, and ship it back to them, right? Not just the code, but the entire container. How am I going to deal with that? How am I going to stop that from being a work stoppage? How am I going to stop that from being a rework method? Okay? So we came to a fundamental difference. Okay? The fundamental difference is security is the checkpoint, right? We've always operated in a checkpoint. Thou shalt not pass, right? And DevOps, if you can see that, are moving at warp drive, right? That's what that actually says. Couldn't make it any bigger, else it kind of took up the whole screen. But DevOps are running at warp drive. They want to ship code, ship code, ship code. They want to get their stuff done and get it out, right? And they're saying, well, you gave me the OWASP top 10 to deal with, and I'm going to deal with those, and I'm going to ship code. And the heck with all the rest, right? Well, how do we add security to a process? And Bill Semp, which I'm sure everybody here has seen talk at some time or seen on YouTube or one of those different places, Adrian's website, talks about care and feeding for developers, right? How do we help them become more secure, right? And they love training and beer, expensive beer, and spicy food. Those are the things that I remember from his talk primarily. So feed them a lot of spicy food and talk about security, right? But how do we work around their process? Okay, how do we work with DevOps instead of against DevOps? It's not this constant back and forth, right? It's not us versus them. It's all of us together. Everybody's on the security team, and everybody's on the dev team, right, in our organization. So how do we do that, right? So I built out this 4-phase approach to dealing with somebody wanting to move into the Docker realm, I guess, right? So the first one was discover. The second one was analyze. The third was deploy. And the fourth was audit regularly. And what I've actually changed because of some new tools is it's now audit continuously, right? Because things have come out over the past few months, past year, like Twistlock, which is a Docker-focused vulnerability management platform, and it's fantastic. It's really, really great, and it's changed the game because with the way the containers are brought up and taken down, it's almost impossible for your traditional non-integrated vulnerability scanner to keep pace with this kind of movement, right? It's so much configuration, so much different looks that we have to give things that it's almost impossible to keep up with it, especially if we're not using shared passwords and shared credentials and we're doing authenticated scans, right? That's the thing that we need something that's integrated at that point. So that's one of the things that we have to look at is how well does our security team communicate with the other team? That's part of the discover phase, right? So we're going to decide whether or not we're ready for Docker, okay? And your dev processes have to be very mature, right? And I'm, as a CISO and somebody who's very process-driven, right, I like to see procedures followed exactly. Predictable, happens every time, everybody knows what to do, and they're singing from the same sheet of music, right? That doesn't sound like your dev team. You need to get on the same page before you're ready to start creating and destroying containers at this kind of pace. You have to have very, very robust fallback options, right? Because again, you're moving real fast, and mistakes are going to be made, okay? So develop those processes to roll back in the case that something goes wrong, and we need to come back to a previous iteration, right? Real easy with snapshots and VMs and stuff like that. A little bit more contentious when you're starting to destroy containers as you're shipping new ones into place. So make sure you got good processes wrapped around that, and decide how you're going to do that and rehearse it, right? So that you don't have extended periods of downtime. You're not rehearsing on the clock, right? And then test the containers to verify that they're actually going to work without root privileges, right? You can avoid using root processes to a certain amount. That's a really good thing. Reduce the amount of places that your root credentials live, and it's going to help you be more successful. This is a little bit less important now, but still very, just good security practice. Then look at, are your apps ready? Right? So are your apps shipped through defined processes? Right? That's one thing that we have to completely change how we think about shipping code. We're not pushing out an installer package or pushing out a build or compiling every time. We're moving way faster than that now. So we need to make sure that everybody is, if you have processes in place right now, that everybody's well rehearsed. Everybody understands what they are, and everybody does follow them. Because you got to look at an organizational type mentality on this. We're no longer just making sure that we have security and technical controls in place. We need to be organizationally mature, right? And organizationally mature means that, are the apps ready? Because we built them the right way. The other thing is relics. I've seen this bite a lot of people, right? They program with old libraries, right? And they forget that they're using that old library under that code. There's been an image going around of a guy, hey, this looks like really old code. I wonder if I can, and then it pans up, it's a stack of wood, and then it pans up and there's an entire Ferris wheel on top of this pile of wood, right? And that's exactly what I've seen a few times, and that have been a big hiccup with these Docker implementations, is somebody doesn't realize they're still using that old library, and they don't build it into the new container, and it hits QA and nothing works, right? So make sure that you eliminate all those relics, or know what they are, know what's in your code, and what you're actually referencing to make sure that you got everything on board, right? Cool. Everybody good on the discover phase? Nope? No questions? All right. Next one is analyze, right? And then let's see what is going to reside in these instances, okay? I've got code that's ready. I got dev processes that are ready. I've got good organizational structure. I've got great policies. What do I actually want to move into Docker at this point, right? There's certain things that you don't want to move to Docker, right? Databases, for instance, not a great idea, just from a performance standpoint. How secure are my jails that are in place to allow people to securely compute in my applications, right? Will any of the direct access methods, and I've seen a couple times where, yeah, all right, I've got this one customer that uses SSH, to get in and dump big amounts of files because they just can't be bothered to put a CSV in the web app, right? So they just SSH over and SFTP and dump this CSV and then run a batch command, right? You're doing that, again, you're having direct access into a shared kernel infrastructure, and that's probably not the best idea. Okay? I can debate that one back and forth, and I'll honestly end up on both sides of the coin on different days and different scenarios. But realistically, this is one of the things that we set forward is that if a client or anybody outside of this organization has SSH access, or anybody outside of my development or security operation has SSH access, we're not going to allow it in Docker just because there's too many gotchas, right? The last part is, this is where we get into that audited containers, right? And this is that pre-check standard that we built in was, will an existing audited container satisfy requirements, okay? So the security team likes to sit back and firefight. That's what we're good at. That's what I've done for over a decade, right? We firefight. We sit back, we find vulnerabilities, we help fix them, we set standards, and we do that stuff, right? But a lot of times we don't have time to be proactive, and it's because we're spending so much time firefighting, right? What we can do with this scenario is now I've got this new technology that's coming out that people are able to grab containers from the hub, and they're able to work in a really, really efficient means, okay? So how do I handle that as a security guy? Okay, and the answer that we came up with was, all right, we're going to start rolling out Docker in 3 months. Let's just use an imaginary 3 months. Okay, I'm going to have one of my engineers on the security side spin up a dev environment, download containers, and pre-check it, and then set an expiration date on that pre-check. Right? All right, I can live with the vulnerabilities that are available. Every container's got some vulnerabilities, right? Every computer, I'd say, has some vulnerabilities, whether we know about it or not. But I'm going to audit these containers, and I'm going to pre-check them for a certain amount of time. And I'm also going to index everything that's in that container that I pulled out from the hub, right? So that I've got a database of everything. So if I have a new vulnerability that comes out for OpenSSH, I know exactly which containers I've approved that have OpenSSH that I can say, now we need to go back and patch. Okay? So I'm going to index them, I'm going to check them for any serious vulnerabilities, and I'm either going to clear them or I'm going to detain them. Right? So what we're doing is building this collaborative environment where I'm saying, hey, dev guy, I know you need this container, submit it to the security team. I've got a list of container IDs that I'm already pre-qualified for us to be able to use. And if yours doesn't fit into that group that I've already qualified, I'm going to go ahead and check it for you. And then you're going to be allowed to ship this at will until this date. So I'm going to give you 4 sprints in order to get through. You're going to get 4 sprints. So if you're on 6-week sprints, that's several months, right? You're going to have this cycle to use this container. And I won't come back to you unless I discover something serious. And I'm going to know what my exposure is. So if I need to put in compensating controls, I can do it ahead of time for that certain amount of time, and then you're going to be allowed to work at will, right? And then I'm going to integrate in a technology that actually also scans those to make sure that the code that's going in or new prerequisites that we're installing into the containers aren't actually also vulnerable. But this is a way for us to say, all right, this guy's good to go. You have him for this amount of time. You really don't even have to check with me before you build on this, but it'll hit our radar before it gets shipped to prod, right? Because obviously I need to know what's in production. I need to know what's in QA to a certain extent. I never know what's in the development environments for the most part. They're just the wild, wild west a lot of times. But this is a way for us to interact with those guys in a proactive way, so that they're not sitting there waiting for security to give them the go-ahead. Right? They're shipping at the speed of Docker, and we're sitting back saying, all right, well, let's check another 5 of these that just came out. Right? You saw there's under 1,000 containers in the Docker Hub. There's probably more than that now. Those numbers are a little bit old, but if we can audit 150 of them, we're probably going to satisfy 99% of the requirements that are going to come across for a Docker implementation. Right? And if you're sticking to the newest available and pre-checking those, you got a much smaller number, under 150. Last I checked, last night I think it was about 148, something like that, right? So having your devs understand, I can check this database of audited containers, right? IDs, however you want to categorize them, and then move at my speed without having to deal with the security guys saying, oh, I guess I can look at that, right? That's going to be a really great thing for them to be able to do what they want to do, move at their speed, and allow us to focus on the things that we really need to focus on, which is the vulnerability management and the compensating controls that we need to put in place. But I do like to say, we like to define a set of standards, okay? And those standards that we get out there, define the acceptable containers from the marketplace. And I said marketplace there because I think they changed the hub name right as I was doing this. Could be wrong, something like that. But it's the Docker Hub. Define the standard OS builds for the host VMs, right? Define what those look like, because great, the containers are good, but the host VM, or I'm sorry, not the host VMs, the host servers still need to be patched, right? We still need to keep those up to date. We still need to define our standards and make that predictable across all the platforms. So when I build a new Red Hat box for you to host on, I know what it's going to look like as I'm shipping through these different iterations and these different cycles in the code. And if we can keep those as consistent as possible across the board, we're going to hit less issues, especially with, I've actually seen a dev environment in 110 trying to ship to a 109 environment, and hey, look, namespaces, or user namespaces aren't available. Right? Well, the prod engineers hadn't upgraded yet. Well, we need to make sure that as they're standardizing on one side, that we're standardizing across the board and making things available as we go forward. I like to define the versions of dependencies that I'm okay with, right? This is what I put OpenSSL up there because I was patching OpenSSL for like 48 hours straight one night, and I still have scars from that one. But I like to define the versions that I'm comfortable with. So if they use a container that isn't audited, or that is audited, but they need another library added in, they know what versions they can go ahead and install as they're working forward, that are going to work A, with our apps, and B, with the security team and our requirements. Does that make sense? Great. Then I like to say, all right, I like to audit with best practice analysis, like Linus. Is everybody familiar with Linus to a certain extent? Michael Boland produces it from Sysify, great Linux hardening tool. I became aware of it when I was in a banking environment. Really helps with hardening a lot of the host VMs, and it's really helpful. There is a container plugin for that as well, okay? So we can audit the containers, but this is, again, hardening. This isn't vulnerability management, right? So when I look at VM, right, I look at my traditional vulnerability management platform. That's really difficult to get set up initially. We spend a lot of time defining what's right, what's not right, setting standards, setting baselines and stuff like that, and then we go into an environment that moves as fast and that we can't keep up anymore, right? I like to use this slide for that. All right, I've got an automated scanner, right? But I'm missing it, almost everything. If you look at the chocks, they're really not helping much, right? Because it's missing a core functionality of what the automated scanner is supposed to do. It's supposed to look, they'll scan the network, right? And look for new instances of hosts and new things like that, but the amount of logs, the amount of data that comes in from an automated scanning tool when you're creating a container every 2 weeks is really, really difficult to keep up with. Okay? So we want to use something that integrates with Docker and integrates with our lifecycle so that as I build a container, I'm managing that container from a security side and from a DevOps side. Right? There's great tools for managing DevOps. There's great tools for managing security in Docker, which Twistlock is still probably my favorite. Just from an integration standpoint and a speed of installation standpoint, it's fantastic. But you don't end up with the misconfiguration side of it where you got this automated scanner, this is how I've always done it, right? This is what I use, this is what all my guys are trained on, but it doesn't work because of the speed that we're moving at now, right? I just really like that picture because it made me laugh, having been an airplane nerd for years. But we want to look at continuous controls on our instances, right? And by continuous, I mean we need to look for best practices before they ship to prod, we need to do regular pen tests to make sure that we have the jails in place that we said were in place, that we thought were in place, right? It's more important to do active pen tests because of the speed that we are moving, right? We are now moving at the speed of DevOps, and that speed means that pen tests are going to find those containers that accidentally weren't destroyed because I wasn't sure, or my rollback plan was to leave this container in place for a couple of weeks while I made sure that everything was good, right? Well, that container's now there 9 months later. How many people have had that happen with a VM before? Oh, that's still online? Yeah, I found those and wasn't amused because I looked at them and they had a Bitcoin miner on it. I said, oh, where'd that come from? That just happened a couple weeks ago. You can implement a vulnerability scanner like Nessus, really helpful to scan those. Again, I look for something that's a little bit more integrated. As I was doing this, we were building a program around Nessus, and then Twistlock came out, and it was like, wow, I can have those two processes integrated, right? So we were doing a manual process to bring these online, bring them offline, bring them online, bring them offline. It was a ton of work for a guy that was managing that Nessus implementation, right? A ton of work to manage those credentials, to manage the IP addresses that we were looking at, to manage the different vulnerabilities that we might see in a different one, and tune and do all that stuff, and then something came out that made it a lot easier, right? So, but you can implement a vulnerability scanner. I also like to say, and this is something that I wanted to get in place, but SCA, right? Look at the code. See if the code is actually doing what we want it to do. Static code analysis, looking at that OWASP top 10, looking at the things that we would expect out of an application from a security perspective. We now have time and budget to do because we are spending less time auditing VMs and patching VMs and dealing with every vulnerability that comes in when they provision a new VM and patch it. It's on a different OS level, right? We're spending less time doing that now. So we've got more time to do things like static code analysis and focus on the privilege escalation. Focus on the lateral movement side of things so that you can say, all right, I know I'm on 110, I know I've got user namespaces, but hey, look, I found a root password in a config file that was available in my web server, right? And we found those before. It happens all the time. And this is what we try to look for because now we can still break that sandbox a little bit more easily than we could before. Tools I've got, like I said, Twistlock, they do vulnerability scanning, runtime defense, they help with compliance, and they actually help manage access control to your Docker repositories, which is really cool. And then Linus is the hardening and best practices analysis that I think is a really great tool for your base builds, your host VMs, and for honestly any Linux boxes that you got out there. Running Linus against it, understanding your risk, measuring your risk against best practices is always a good idea. So it's something that I really like to mention all the time. These are some of the articles I mentioned. If you guys want those, I will post this somewhere and get it out on Twitter somehow at some point over the next couple of days. And I'm actually going to be doing this entire talk in a CyberE Open article. So if you guys aren't on CyberE, this will all be in CyberE Open by the end of next week. Not the slides, but all the raw information and the entire security principle. I'm working with a designer to do some really nice graphics that'll be really good for upward visibility for everybody. So keep an eye open on CyberE Open because that'll be coming out pretty soon. This is the other cool stuff, just a few things. That's the talk, Iron Geek site, that I was talking about earlier. Bill Semp's Care and Feeding for Developers. It's fantastic. It inspired a lot of how I built the program for the customer and helped us understand what they wanted from us, right? To make it a two-way, I have to look at them and say, what do you need from me? And this is how I can give that to you. Now, I need you to do this for me. And that back and forth was really inspired by a lot of what Bill said. Here's my contact info, Twitter handle, my name, title, email address. If you guys need to get a hold of me, please feel free to reach out at any time, and I will keep you all up to date as we go forward with this. I got a little bit of time for Q&A. 15 minutes for Q&A, actually. Any questions? Yeah.
Is this presentation available anywhere that I can share with my developers?
You'll be able to watch it on YouTube probably by lunchtime with the way you guys move these days. But yeah, it'll be available there. Again, I'll have that article built out as well. So it's all about how we learn, right? If I learn best by watching a movie or watching a video, that's the best way. I'll also have it as an article for somebody that wants to just sit down with a 5-page article and read it.
That'd be great.
Yeah. Anybody else? All right. Thanks, everybody.